Thank you very much. Thank you very much for staying until the last talk of today, of this session, of the AI and industry session. So it's really a pleasure to be talking to you a little bit about some of the use cases that we have, some of the internal capabilities that we have built, and also how those internal capabilities allow us to do some research and explore further avenues in natural language processing. Okay, so the agenda today that I will cover is natural language processing in healthcare, a brief introduction to what we mean when we talk about this topic. I'll talk about our natural language processing engine, which is this internal capability that we have built, this pipeline that we have built as a team. Then I am part of this IT organization, and we do receive requests, and we need to deliver these requests as products, right? So we go from not just an idea to model, but also we have to go on to production. So I will briefly talk to you a little bit about this use case that is healthcare professional feedback classification. I'll tell you a little bit more about that. And then starting with that topic, that use case, which is centered around text classification, I will talk about challenges of working with imbalanced data for text classification. So maybe you've seen this slide yesterday also from Gunther Janssen's talk. We have reached a pivotal moment in healthcare where we have tremendous amounts of data, multimodal data. Multimodal data analysis was a huge topic in the AI and healthcare track that we also organized. But there's also technological advances that are offering new ways of collecting and analyzing data and enhancing care. And at the same time, these machine learning advances, just in the last 5 years, the field of natural language processing completely was accelerated by some of those advances. And we are now taking advantage of those today. And the combination of these advances provide opportunities to provide patient outcomes. And we always put this patient at the center whenever we talk about healthcare analytics. So when we talk about natural language processing in the biomedical domain, we can talk about these natural languages where, for example, in scientific information sharing in publications, this is a very domain-specific, terminology-rich language, right? So these are natural languages, so to speak, in that this is written by humans, but they're very domain-specific. But there are also DNA sequences, protein sequences, chemical formula. These are also languages codified by humans that natural language processing methodologies can be applied to. Today, I will focus more on natural languages as natural languages, but more on this scientific content containing text. As I mentioned to you, our focus on natural language processing use cases or natural language processing advances was triggered by the fact that we were receiving so many of these use cases that were based on text analytics. For example, we needed to do fuzzy matching and search in PDF documents for one of the use cases. Scientific information search, relevance ranking, information retrieval. These are, common use cases that you would receive in understanding the customer here being either the healthcare professional, or it could be an internal customer within Roche. Healthcare professional feedback classification. Here we use multi-label classification, sentiment analysis, and record matching. This would be non-semantic matching. These are some of the tasks that we kept repeatedly getting as requests from different business units. And so we saw that most of the requests we received were based on unstructured data or text data. Similar steps were performed repetitively with minor changes. So we thought, why don't we have this Lego approach, a modularized approach that will speed up rollout and also minimize effort on our part? So we also wanted to make sure that we were able to co-create with the subject matter experts at Roche, because this is true that we have that expertise within the company, so why don't we co-create with these colleagues for interpretable, explainable, and more accurate solutions with Roche subject matter experts. So when you examine this natural language processing pipeline, you see that it starts with text and then goes through some pre-processing, then you take it through some machine learning algorithms, supported by pre-trained models, fine-tuning and active learning, and then interpretation of results. This is a no-brainer. It's a common pipeline that we kept repeating to apply to different use cases over and over. So what we knew that we needed a comprehensive Python-based library for data scientists, an interface to high-performance computing, a home for NLP data scientists that is easy to use with state-of-the-art performance on models, and a platform where data scientists can train, store, and use robust natural language processing models. This is what we needed. We knew this. But we also had a dream. We thought if we were able to provide scalability, speed, reproducibility, provided by this platform, with seamless user experience, which is simple, adaptable, cool. Coolness is critical. With a shared purpose, bringing the Roche data science community to create value together, to accelerate collaboration. Then we thought we could also, bringing all of those great minds together, this will also, of course, trigger new areas of research and developing new models and architectures to deliver state-of-the-art models for Roche-specific use cases. So this was our dream in this sort of iterative circle. And the natural language processing engine, we call it NLPE for short, is a pipeline powered by best practices. So as I mentioned to you, we are part of this IT organization. We're trying to serve these products. So we also have a big focus on best practices for operationalization, MLOps, etc. So we have this end-to-end platform with an MLOps platform where we have pulled together these NLP tasks related to classification, text similarity, sentiment analysis, topic modeling, etc., under one big code repo, basically. And these, as I mentioned to you, we are powered by best practices, and in fact, building the NLP engine also powered our best practices effort, where best practices in coding and development, code sharing, how to collaborate with each other, making NLP-related data, information, and insights fair. There was a big focus on fair standards, findable, accessible, interoperable, reusable during our AI in healthcare session as well. With efficient technical integration with minimum refactoring efforts, CI/CD pipelines, and also deep interoperability, right? So these were some of the principles that we had in mind as we built this NLP engine, and actually that powered also our best practices as a team, making us stronger, hopefully. So the NLP engine, why an internal capability? Why do we need this? We needed a powerful NLP library. This was clear, a state-of-the-art NLP for common multilingual NLP tasks. So we are part of the organization where we serve a lot of the affiliates, meaning the different countries. And so had to make sure that we were serving all of these multilingual NLP tasks as well. We needed a biomedical vocabulary library. This is clear. I mentioned to you that this is a very domain-specific language. And we also wanted to make sure that this was a Roche customized text embedding library as well. So allowing us to have these 3 layers of capabilities for Roche-specific use cases, one of which I will describe now. So healthcare feedback classification, this is a very simple use case, let's say, to drive home the message. Feedback is received from the healthcare professional. Then Lisa manually checks all healthcare professional feedback each month. She splits this free text into several sentences based on her experience, right? That's the subject matter expertise. She classifies each sentence into insight and non-insight, and then the insights are classified into, let's say, 7 areas. It depends on which business unit is asking for this. It can be 7 to 250. But this task each month takes 2 days, for Lisa. What is the problem? There's manual effort, it's time consuming, and usually the labeling is performed by an external agency. And the other thing is there can be inconsistencies in classification. If you remember this blue dress, it is blue. Okay, so for the HCP feedback classification, this was a simple data pipeline. We start with data ingestion, train machine learning models, predict class, and then reporting and visualization for business units to visualize the model predictions using a customized dashboard. In fact, Igor is in the audience from this team. But one challenge remains, right? So I mentioned to you about the inconsistencies with that blue dress. It's hard to annotate data consistently. It's easy to recognize the pictures on the left as cat, the pictures on the right as not cat, but the pictures in the middle, it's hard for even human beings to classify, except if you're given instructions. So you would need subject matter expertise, right? And so this, obviously we don't have a cat labeling problem, luckily. But we, as I mentioned to you, we have these subject matter experts in the company, obviously. So we said, why don't we take advantage of the fact that we can use these active learning methodologies where the subject matter expert comes into the picture to correct mislabeling and to add labels to unlabeled feedback so that we can have this, let's say, iterative loop for human-in-the-loop machine learning. So I hope I was able to tell you a little bit about this healthcare professional feedback classification use case, which is, as I mentioned, a relatively simple use case, just to drive home the message that this was a use case where we had this machine learning with active learning involved with a human in the loop. It's scalable now for different number of labels and amounts of data. It's multi-language, it's fast, and it saves money, basically, because you don't need to pay an external company for labeling, and it frees up valuable time for the subject matter experts as well. And this use case was powered by this NLP engine. The NLP engine, you can think of it not only as a platform, but also as a team of people coming together to solve certain problems, right? So it's a collaborative effort, making sure that so one person suggests, oh, why don't we use active learning for this? One person just suggests, well, why don't we use multi-label classification for this, right? So you can think of this engine as not just a tool, but also as a team effort. So I talked to you about these really great opportunities, or this nice success of this healthcare professional feedback classification, which is a text classification problem. But text data in the biomedical domain is a needles in a haystack problem. And especially if you have multi-label text classification, it's very hard to find these needles in a haystack due to data imbalance and also, or class imbalance and co-occurrence. So actually, what I'm describing to you is led to a paper publication. This initial idea was a challenge where we had these PubMed data sets, right? And we had these multi-labels. For example, for this particular text, it could be COVID-19, ICU, Spain, Madrid, and then ICU capacity. These can be the labels. And then human is also a common label. You can imagine that human is going to be a common label in many of these publications. So that's a head label, right? Whereas, for example, ICU capacity is a rare label. And finding those rare labels is actually the biggest challenge, not just for PubMed or scientific information retrieval, but for any text classification with multi-label text classification is involved. To address this class imbalance problem, binary cross-entropy or resampling reweighting are commonly used methodologies, but they don't deliver, especially because of class imbalance and co-occurrence for the multi-label text classification problem. So we propose a distribution balance loss, which is actually a computer vision solution that was proposed earlier with these 3 layers: focal loss, rebalanced weighting, and negative tolerant regularization. And we saw when we examined our results, we saw that the distribution balance loss that we proposed performed better than support vector machine or binary cross entropy, these baseline models, when you look at this first column, which is looking at the F1 score for all of the labels. But if you focus on the head labels, the performance is similar to SVM. But if you focus on the tail labels, where tail labels means those rare cases where you don't have enough number of articles associated with that label, the performance increased compared to these baseline methodologies. And this was published last year at NLP, where we presented. Another approach could be, for example, complementing these rare classes with synonym matching and NER. And here we participated again in another BioASQ challenge where we did get an award for precision, high precision. And here the idea is to combine these approaches together so that to be able to address that needles in a haystack problem. So the scarcity of annotated and balanced data challenges the use of supervised learning. I think we all can agree on that. And supervised learning is great when you have enough labeled data, but manual data annotation is laborious, time-consuming, requires specialist expertise. So there are now, for a while now, there are now approaches that go beyond supervised learning to address these challenges. And this was also a publication from last year, end of last year actually, in Patterns, where we summarized some of these methodologies to address these needles in a haystack problem that go beyond supervised learning, such as semi-supervision, active learning. I just mentioned to you about this active learning as a part of the healthcare professional feedback classification tool. I mean, you've heard of zero shot, few shot, et cetera, right? So some of these methodologies we summarized in this Patterns publication last year. So the 3 takeaway messages I have is that the NLP engine framework provides scalability and reproducibility, which is key for us because we do want to deploy fast solutions that are scalable. And approaches beyond supervised learning can unlock the potential of machine learning by helping find needles in a haystack. And my 3rd take-home message is that collaboration, open source, and open science can help propel a data science team. So I'd like to end with this visual. I think you've maybe seen this also visual in our booth, where we put the patient at the center, right? So to combine technologies, machine learning for faster, more efficient research and development, but also improved patient outcomes. And so I wanted to end with that note that personalized healthcare, putting the patient at the center and addressing their needs is key for us at Roche. So this is, I think you will find when you visit our booth more information about this. And this is doing now what patients need next is our motto. But I saw in several talks that colleagues mention about opportunities to work at their institutions. So shout out to anybody that wants to work with us, either collaborate with us. We're very open to collaboration, working together to find these interesting solutions and interesting questions for addressing some of these challenges in healthcare. Thank you very much.